I'm Dr. Roger, and this is differential equations, in particular first-order linear. The first step for first-order linear is to confirm that it's first-order linear, which is a separate issue, and then write your equation in standard form, which is y prime by itself, not even a coefficient. Just one y prime plus some function of t times y, and that function can in fact be a constant, it is in this case, equals some other function of t. So, standard form is y prime plus p of t y equals g of t. And make sure you are in standard form. Then we will find the integrating factor, which I'm going to write as mu of t, and that's defined to be exp of the plane y coefficient, the integral of the plane y coefficient. So the integral of -2 dt, where exp is notation meaning e to that power, because we're not very good at e to the power of an integral. If we write several steps like that, we lose the fact that the integral is in an exponent and do silly things. So this is exp of -2t. There's a plus c, but we'll always choose c equals 0 here. So that's e to the -2t. So in general, find the integrating factor, which is mu of t equals exp of the integral of p of t dt. Once you have your integrating factor, multiply both sides of the equation in standard form by mu of t. So multiplying both sides by e to the -2t, I have e to the -2t y prime minus 2 e to the -2t y equals t squared times e to the 2t times e to the -2t, and that gives you t squared times e to the 0, which is t squared times 1, or just t squared. Once you've multiplied, your left-hand side, which I'll abbreviate LHS, will be mu y prime plus p of t mu y. And we will write the left-hand side as a product rule derivative, mu times y quantity prime. If you check your product rule, this is the first times the derivative of the second is mu y prime plus the derivative of the first times the second, where the derivative of mu is an exponential, so its derivative is the exponential times the derivative of the exponent, and the derivative of the exponent is the derivative of an integral, so that's just p of t. So that will be p of t mu y. Your left-hand side will always be the product rule mu y quantity prime. So this is e to the -2t times y quantity prime equals t squared. There is a formula that takes you directly to the answer with first-order linear. I don't like using it because there's no checks as you go through to make sure you didn't do something careless. In this case, we can do the product rule right now. The derivative of e to the -2t times y is the first times the derivative of the second is e to the -2t times y prime, plus the derivative of the first times the second is -2 e to the -2t times y. So this is the correct product rule derivative if we're going up. So we've rewritten it correctly as we go down. This allows us to integrate both sides dt. On the left, the integral of e to the -2t y quantity prime dt. On the right, the integral of t squared dt. Left-hand side is fundamental theorem. The integral of a derivative or derivative of an integral takes you back where you were. So this is e to the negative 2t times y. Right hand side is 1/3 t cubed plus c. You can write plus c on both sides, but if we had a plus c1 on the left, plus c2 on the right, you can subtract c1 from both sides, and that just gives you a plus c on the right. Traditionally in differential equations, we'll just write the plus c on one side when we integrate both sides. Once we've integrated dt, solve for y, if possible. In this case, I'm going to multiply both sides by e to the 2t, which gives me y equals 1/3 t cubed e to the 2t plus c e to the 2t. Solving first order linear is always this cookbook process. We know the exact steps so long as you can integrate p of t to get mu and later integrate your right hand side, which is g of t times mu. We get to the answer through a sequence of known steps. Most common error that I see is if you forget to put in a plus c here and you get to the end and say, oh yeah, there's supposed to be a plus c, and just stick it in there, we forget that this c is divided by your integrating factor mu, or multiplied by 1 over the integrating factor. It's not just a plus c at the end, because c is always over mu of t. This is first order linear ordinary differential equations. Come back soon for my next video. With math, there's always more.